Hey everyone, welcome back to another episode of my podcast, Waves in Action, the podcast where we explore the science behind everyday tech and natural wonders all around us. I'm your host, Caitlin Passion, and today we're tuning into the world of walkie-talkies, those small handheld radios that use invisible energy to send our voices flying through the air. Let's start with the basics. Walkie-talkies are portable, two-way radios that allow people to communicate wirelessly over short distances. Think of them as radios with a talk button. When you press that button, that's also known as a push-to-talk, your voice gets converted into electrical signals. Then those signals are turned into radio waves, a type of electromagnetic wave, and sent out through the air. But how does the other walkie-talkie know how to pick up your voice? That brings us to frequency. Walkie-talkies transmit using ultra-high frequency and sometimes very high-frequency radio waves. Ultra-high frequencies usually range from 462 to 467 megahertz. For two walkie-talkies to communicate, they must be set to the same frequency channel. Otherwise, they'll be speaking in different languages, so to say. Now here's where wave science comes in. Let's break down the wave characteristics that affect how walkie-talkies work. First up is frequency. The frequency determines how many wave cycles happen in each second. Higher frequency means shorter wavelengths, and that's actually perfect for walkie-talkies because shorter wavelengths can travel better through obstacles like buildings and other things. That makes ultra-high frequency ideal use in cities or schools. Next is amplitude. Amplitude refers to the strength of power of the signal. A stronger amplitude means the signal can travel farther, but there's a trade-off. The higher the amplitude, the more energy it uses. Now what about speed? Radio waves, just like light waves, travel at the speed of light, which is around 300,000 kilometers per second. That's why there's barely any delay when you're chatting on walkie-talkies. Your message is zipping through the air nearly instantly. But what if your signal is weak or your frequency changes? If the frequency changes and both walkie-talkies aren't aligned, they won't connect. You'll either hear static or nothing at all. And if something is blocking your signal, like the thick concrete walls or some sort of metal, the waves may weaken, bounce off, or get absorbed. That's why walkie-talkies work best in open areas or with line-of-sight communication. So whether you're at a concert, working security, camping in the mountains, or just playing spies in your backyard, walkie-talkies are a super cool example of how we use electromagnetic waves in everyday life. And to sum it up, walkie-talkies use radio waves to send your voice wirelessly. They rely on specific frequencies like ultra-high frequency to connect. Wave properties like amplitude, wavelength, and frequency all play a role in how well they work. And yes, it's all happening at the speed of light. For today's episode, I used info from How Stuff Works, Wikipedia, and Hytera's tech blog, all probable sources that help break down the science behind technology and other things. Thanks for joining me today on Waves in Action. If you like this episode, don't forget to hit that subscribe button and share with your science-loving friends. Until next time, bye!